In this video, we are going to look at the ions and isotopes sheet. So we're going to start by just counting the protons, neutrons, and electrons of each atomic model, and then figuring out the mass number and the charge based on the number of subatomic particles. So let's go ahead and get started. So in number 1, we have protons we need to look at first, and we know that protons are shown by the symbol P+, and it tells us that there are 15 protons. So we're going to put in 15. The number of neutrons is shown by the N0 symbol, 0 as the superscript, and it says that there are 16 neutrons, so we'll go ahead and fill that in. And then electrons, we know, are not in the nucleus. They are on the outer shells. And so we actually need to count how many electrons. These dots that are on the outer shells are the electrons, which is going to be abbreviated E-, but we need to count them. So we'll go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 electrons. Now, the mass number we know is equal to the number of protons plus the number of neutrons. So all we need to do is add those two values up. So we'll do 15 plus 16. And of course, that gives us a mass number of 31. So now we have the mass number, and then the last part is to figure out the charge. Now we know that in an atom there are two types of charged particles. We know that protons have a positive 1 charge, and electrons have a negative 1 charge. So we need to look to figure out what the overall charge of the atom is. So we kind of think of it as a balancing act of a scale. So if we have 15 positives and 15 negatives, then overall we don't have any charge. We have a charge of 0, or that means that it is neutral. So we'll put a charge of 0 here because we have equal numbers of protons and electrons. But sometimes that won't be the case, and we will end up having a charge on our atom. Looking at model number 2, once again, let's figure out protons first by looking at this P+ symbol. Still 15 protons. Neutrons, it's telling us there are 16 neutrons in the nucleus. And then electrons we have to count. So we'll start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons. Our mass number is going to be our protons plus our neutrons, so that'll be 15 protons plus 16 neutrons, so still a mass number of 31. And then our charge, once again, we need to look at our number of protons and our number of electrons. And this time, we have 15 protons with a +1 charge, and we have 18 electrons with a -1 charge. So if we have positive 15 and negative 18, that's going to give us an overall charge, an extra -3. So we have an extra -3, so that is our charge, an overall charge of -3. Looking at number 3, protons, it tells us that there are still 15 protons. Neutrons, there are now 15 neutrons. And electrons we have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Mass number is going to be protons plus neutrons. So in this case, 15 plus 15, which gives us a mass number of 30. And then for our charge, we look at the balance of positive and negative of protons and electrons. We have 15 protons and 15 electrons, giving us equal positive and negative for a charge of 0. And then last but not least, model number 4. This time we have 16 protons, and we have 16 neutrons, And then we need to count our electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 electrons. Our mass number, we add protons plus neutrons, so 16 plus 16 is going to give us a mass number of 32. And then our charge, we need to look at the balance of protons with electrons. This time we have 16 protons, but we also have 16 electrons, so we still have a net charge of 0. Now that we've finished recording all of our data, we have it in one place, and we're going to use our found data to fill in this chart, telling us what makes an atom a new element, or an ion, or an isotope, or a molecule. So let's look at our data here and use the clues that are given to determine what makes each of these things. So our first clue says number 1 and number 3 are different isotopes of phosphorus. So looking at number 1 and number 3, we need to look at what's different about these and what's the same about them to figure out what makes something an isotope. So I'm looking at the number of protons. We have 15 protons on both, so isotopes have nothing to do with protons, same number of protons. We have the same number of electrons. The thing that I'm seeing that's different about these is the number of neutrons and the mass number. Number of neutrons and the mass number. So going back to our chart over here, let's see if any of these descriptors talk about either number of neutrons or the mass number. So add or subtract an electron, that's probably not it. No, add or subtract a neutron. Okay, so if we add or subtract a neutron, that makes something an isotope based on our data. Okay, and so we can go over here now and define an isotope as atoms with the same element, because they have the same number of protons, element, but different numbers of neutrons. Or we could also say different mass numbers. Okay, so next let's look back at our second clue. It says number 2 is an ion of phosphorus. So looking at number 2, we know that number 1 and number 3 were still phosphorus. All 3 of these are phosphorus, so we could label them with phosphorus's chemical symbol, which is just a capital P. All of them are phosphorus, but number 2 is an ion of phosphorus. So let's see what makes something an ion. Well, number 2 still has the same number of protons. It has the same number of neutrons as number 1, so that must not make something an ion. But what I notice is that number 2 has a charge, where number 1 and 3 do not have a charge. And to have that charge, that had a different number of electrons. So if we change the number of electrons and something has a charge, then it makes it an ion. So we've used isotope here. So let's look. If we add or subtract an electron, that would be exactly what we did. That forms an ion. Okay, so an ion is just an atom with a charge. And that's due to the atom having different numbers of protons and electrons. Okay, let's see. Coming back, number 4, our last clue, says number 4 is not phosphorus. So numbers 1, 2, and 3 are all phosphorus atoms, but number 4 is not a phosphorus atom. So looking at number 4, the thing that is different, that only number 4 is different, is the number of protons. So apparently, when we change the number of protons, no longer 15 protons, but 16 protons, it makes a new element. Okay, so let's look back over here. An atom, if we add or subtract a proton, it creates a new element. Okay, So the subatomic particle that defines the identity of the atom is the proton, because if we change the number of protons, then we no longer have the same element. We have a totally new element. So the identity of the atom, meaning what type of atom it is, whether it's fluorine or chlorine or phosphorus or sulfur, is identified by the number of protons. And then last but not least, we're not talking about this too much yet, but if we add another atom, we put more than one atom together, we create a molecule, which is a grouping of more than one atom. A molecule. So we have our whole chart filled in. We have a few more blanks to fill in on the right here. So let's look through those. Two atoms are isotopes if they have the same number of protons but different numbers of what? So we can refer back an atom. If we add or subtract a neutron, we form an isotope. So they must have different numbers of neutrons. The next one says two atoms are isotopes if they have same numbers of protons but different numbers of neutrons. We actually filled that in twice, so we don't need to do that again. We'll just cross that out. And then last but not least, an atom is an ion if it has different numbers of blank and blank. So we said that to be an ion, it had to have a charge. So we care about those charged particles. So for an atom to have a charge, it needs to have different numbers of positive protons and negative electrons. So this is just a really good summary for us moving forward when we're working on this vocabulary. So now let's use that to do some practice here on the back of our sheet. Alright, so we have a paragraph of information at the top that we want to read first. It's always important to read information. So it says atoms are most stable when they have 8 electrons in their outermost or valence shell. So the outermost shell, not the one all the way in, but the one that's furthest out. This is called the valence shell. Valence. So atoms are most stable when they have 8 electrons in their outermost or valence shell. This tendency of atoms to desire 8 valence electrons is called the Octet Rule. It's an important rule for us to know. The Bohr models below depict atoms which do not have a full octet. You need to determine what the charge of the atom will be once it reaches a full outer shell with 8 electrons. Atoms tend to do whatever requires less work. For instance, an atom with 2 valence electrons will lose its 2 electrons rather than have to gain 6 more. Okay. So this is what drives chemistry right here. This is what makes chemistry happen. The idea that every single atom in the world wants to have a full octet, meaning 8 electrons in their outermost energy level or shell. And so if they don't have a full octet, for instance, in number 1, there's only 1 electron in the outermost energy level. So if they don't have that full octet, then they will work to get that full octet by either gaining or losing electrons. And they'll do whichever one is the easiest thing to do. So, let's start by going through this, and this will probably make a lot more sense as we go. It just takes a little bit of practice to get used to. So first of all, we need to identify our element. So a number of protons, well, it says we have 11 protons. Number of neutrons is 12. Those are both in the nucleus. Now for our electrons, we just need to count our dots. We're counting all the electrons, not just the valence one, but just the total number of electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and the subatomic particle that tells us which element we have is the proton. So now that we know that we have 11 protons, we need to look at our periodic table and determine which element has 11 protons. And so we're just finding element number 11, and we're looking at the atomic number, which is the whole number at the top, and element number 11 is sodium. So this atom must be a sodium atom, chemical symbol Na. Next, it's asking us how many valence electrons we have. And remember, valence electrons are the electrons only in the outermost shell of the atom. So now we're just looking at this outermost ring of the atom, and there's only one electron in that outermost shell. So we have one valence electron. Now we need to decide whether to add or take away electrons to obtain a full outer shell. And remember, we need to get to 8. So would it be easier for this atom to just lose that one electron, or to have to gain 7 more electrons? Well, it's definitely easier to remove just one thing than have to gain 7 things. So we're going to remove that one electron. Remove that one electron. So when we do that, when we remove that one electron, this outermost shell is no longer the outermost shell. Now, our next shell in is our outermost shell. This green shell here is now our outermost shell. And that green shell already has a whole bunch of electrons. It already has 1, 2, 3, 4, 5, 6, 7, 8. So now we have a full outermost shell because by just knocking off that one electron, we bumped in, and now this is our valence shell. Valence. So it's a really convenient thing that atoms can do. Just lose that one electron. Now we have a different outermost shell. And that outermost shell is now full. So now, once we, it says determine the charge once the electrons are removed or added to form an octet. So we started out with 11 protons, so 11 positives, and 11 electrons, but now we removed one of those 11 electrons. We only have 10 electrons left. So now if we have 11 protons and 10 electrons, that gives us an excess of 1 proton. So we have a +1 excess. So we have a new charge of +1. So is this an ion? Yes, because we have a charge. Yes, this is an ion. Looking at number 7, we start by identifying our element. So our number of protons is going to be 17 protons. Our number of neutrons is 18. And we have to count our electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. To figure out our chemical symbol, we need to use the number of protons, 17, or refer to our periodic table. We'll find element 17, and that happens to be chlorine, Cl. So symbol, capital C, lowercase l. Next, we're finding the number of valence electrons. So we're just looking at this outermost shell. We're not looking at the other ones, just that valence shell. And we need to count up the electrons in that outermost shell. So we have 1, 2, 3, 4, 5, 6, 7. 7 valence electrons in that outermost shell. Now let's decide whether we should add or take away electrons to fill that outer shell. So we already have 7 valence electrons. In order to get to 8, we either need to lose all 7 of those or just gain 1 electron to get to 8. So it's going to be a lot easier to gain 1, so we're going to add 1 electron to get to 8. So we can just add that right here, pretend we're adding it. Now when we add 1 electron, we need to determine whether or not we have a charge and what that charge will be. So we started out with some protons and some electrons. We started out with 17 protons and 17 electrons, but we added 1 more electron. So now we have 18 electrons, which gives us an excess of negative charges, 1 extra negative charge. So we have an extra -1. So that is our charge, -1. And is this an ion? Yes, because it has a charge. And specifically, to use a little bit more vocabulary, we have a special word for a positive ion and a special word for a negative ion. A positive ion is a cation, and a negative ion we call an anion. So we'll specifically put that this is an anion. Now let's go back and fill that in for our last problem as well. For number 1, we had a positive charge here, so yes, this is an ion. This is a cation. Cation. All right, looking at number 2, moving on to number 3. Let's identify the element. Number of protons. There are 10 protons. Number of neutrons. We also have 10 neutrons. And we need to count our electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To figure out our symbol, we look on our periodic table for the element that has 10 protons. And that looks like it will be neon, Ne. Chemical symbol, Ne. Next, we need to look at the number of valence electrons. So we're only looking at this outermost energy level. We're not looking at any of the other energy levels. So only looking at those outermost electrons, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. 8 valence electrons, I'm sorry. Now we need to decide whether to add or take away electrons to obtain a full outer shell. And a full outer shell, remember, is an octet, meaning 8 electrons. Well, we already have 8 valence electrons, so we don't need to do either. We don't need to add or remove, so I'm just going to put 0. We don't need to add or remove any electrons. We already have a full octet. Now determine the charge once electrons are removed or added to form an octet. So we didn't remove or add any. So we have positive, negative. We started with 10 positives. We still have those 10 positives and 10 negatives, and we still have 10 negatives. So we have equivalent numbers of protons and electrons, giving us a charge of 0. So is this an ion? The answer to that is no, it's not an ion because it does not have a charge. We didn't have to add or remove any electrons to get to a full octet, so this is not an ion because it does not have a charge. Last, number 4, it says use the provided information to draw the Bohr model for sulfur. Okay, so let's start by identifying how many protons and neutrons we have, and we know that our protons and neutrons go in the nucleus, which is this gray part. So P plus would be our number of protons, and 0 is our number of neutrons. So we're told our number of neutrons, that would be 16. But we're not told our number of protons, so we need to figure that part out. And how can we figure that out? Well, it tells us that we have the element sulfur, so we can refer to our periodic table. We can find sulfur on the periodic table and look at its atomic number. So sulfur's right here, and it has the atomic number of 16. And so that tells me that this atom should have 16 protons. 16 protons. And it tells us that we have 16 electrons, so we can go ahead and fill those in as well. So when we fill in electrons, we don't put any in the nucleus, we only put them on the rings. And remember, the first ring only holds 2 electrons, and then every ring after that, at least for now, holds 8. So we put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we put 8 on the second ring. So go down to the third ring. 11, 12, 13, 14, 15, and 16. All right, so we filled in all of our electrons. So then, now that we've drawn our model, it says, will sulfur gain or lose any electrons? Why or why not? So remember, to determine if an atom will gain or lose electrons, we're looking at the valence shell, meaning the outermost shell. So we're just looking, whoops, let's go a little bigger there. We're just looking at this outermost shell. And we are trying to get to 8 valence electrons, meaning electrons in that outermost shell. Right now, we don't have 8 yet. We have 1, 2, 3, 4, 5, 6 electrons. So we either need to lose all 6 of those electrons, or we need to gain 2 more. And so it'll be a lot easier for the sulfur atom to just gain 2 more electrons to get to a full octet. So A, we're going to put that it will gain 2 electrons, and I'll abbreviate E minus, to reach an octet. All right. What will the charge on sulfur be? Well, if we gain 2 extra electrons, we still have 16 protons, but now we don't have 16 electrons, we have 18 electrons. So we have 2 extra negative charges, giving us an overall charge of -2. So will sulfur form an ion? Yes, because it's going to form that ion with a -2 charge when it gains those 2 extra electrons to reach an octet. What other elements on the periodic table do you predict will behave like sulfur, and how do you know? Well, if ion formation, forming an ion, has to do with how many valence electrons, we're looking for other elements on the periodic table with the same number of valence electrons. So coming over to our periodic table, sulfur is in group 16 of the periodic table, and it has 6 valence electrons. And everything else in this group 16 also has 6 valence electrons. So all these elements will form ions with a -2 charge. So everything in group 16 will behave like sulfur. So we'll put everything in group 16. Groups are also, groups just a word for column of the periodic table. So that is the end of this tutorial.